Consider this picture. Here we have the y-axis, and here we have the x-axis, x and y. And I put 2 points on the y-axis, x sub 1 and x sub 2. 2 points, I'm sorry, those are on the x-axis. And 2 points on the y-axis, y sub 1 and y sub 2. Now I'm going to plot 2 points. Here's the first point with the ordered pair x sub 1 comma y sub 1. Here's the second point with the ordered pair x sub 2 y sub 2. We're interested in the distance between these two. We call it d. We draw the lower leg, and that distance is described by the absolute value of the x sub 2 minus x sub 1. And then we draw the vertical leg of the triangle, and that distance is described by the absolute value of y sub 2 minus y sub 1. It's a right angle that's made right here between those two legs. So what we have is a right triangle. Pythagoras came up with a formula for a right triangle. The d distance between these 2 points, that is the side opposite the 90-degree angle that I've drawn in the box. That side of a right triangle has the name hypotenuse. D is the hypotenuse of the right triangle. It's the side opposite the 90-degree angle. Pythagoras said if you square the hypotenuse, it's equal to leg squared plus leg squared. Now, if we want to find out what d is, we take the square root of both sides. Usually we do plus or minus, but here we only take the positive square root because it's going to define the distance between these 2 points. Distances are always positive, never negative. So we just use a positive square root of the absolute value squared plus absolute value squared. But if you're going to square it, that means that the whole value was going to be positive anyway, so you do not need to take the absolute value. We'll do parentheses instead. So the d is equal to the square root of parenthesis x sub 2 minus x sub 1 squared plus parenthesis y sub 2 minus 1 squared. And that you want to put in a cloud because that defines the distance formula between the 2 points x sub 1 y sub 1 and x sub 2 y sub 2.